memory, resources, and why. It works on my machine is alive. By now, we understand execution and persistence. Next, we confront the invisible constraint that shapes all backend systems. Resources are finite. Most backend failures are not caused by logic errors. They are caused by systems hitting limits they didn't know existed. Let's start with memory. Every process believes it has its own large, private memory space. This is an illusion created by virtual memory. Virtual memory maps a process's addresses to physical RAM. The kernel maintains this mapping and enforces isolation. This illusion is incredibly powerful and incredibly dangerous because virtual memory feels infinite until it isn't. When memory demand increases, the kernel uses paging. Active memory stays in RAM, inactive memory is moved out, and under pressure, the system starts reclaiming aggressively. This is when things get ugly. Latency spikes, processes stall. Eventually, the kernel kills something. Often, it kills your service. Now let's talk about resource limits. A process is not allowed to consume infinite memory, CPU, file descriptors, threads. Limits exist to prevent one misbehaving process from destroying the system. But here is the trap. Most developers never hit these limits locally. Your laptop has fewer services, no noisy neighbors, and forgiving defaults. Production does not. This is where the phrase, "It works on my machine," becomes meaningless. Your machine is not constrained the same way. Resource pressure also explains performance pathologies. CPU throttling that looks like slowness, memory pressure that looks like random failures, limits that look like mysterious crashes. These are not bugs in your code. They are reality asserting itself. Senior engineers learn to read resource signals, memory usage trends, CPU scheduling behavior, allocation patterns. Not to optimize prematurely, but to avoid catastrophic failure. Mental models, what must stick. Virtual memory is an illusion managed by the kernel. Memory is finite, even if it looks infinite. Resource limits exist to protect the system. Production environments are constrained by design. Performance failures often originate in resource pressure. Common senior-level failure pattern. Let's just increase the memory limit. This often hides leaks, delays failure, and increases blast radius. Limits are not the enemy, they are feedback. Why this matters for workflow. Every deployment changes resource behavior, new allocation patterns, new concurrency levels, new pressure points. If your workflow ignores resource constraints, CI passes but production fails, rollbacks don't help, incidents repeat. A safe workflow assumes resource pressure is normal and plans for it.